Good day, everyone. Here's the first lesson for the new unit, which is called Exponent Laws. This is lesson number 1 from Unit 4. We're going to be dealing in this unit with learning about the exponent laws again, and I say again because the exponent laws are things that you've studied in junior high. The difference is the ways in which we're going to apply the exponent laws are going to be elevated to a high school level here. And you can think of what I'm telling you as meaning the problems become more complicated. But before we get to more complicated problems, we have to review those exponent laws. So this is on page 1 of your new Unit 4 handout. And we're going to start off by defining something which is called an exponential expression. And we see exponential expressions in a lot of areas in high school math, all the way from 10C into the -1 and -2 courses up to the grade 12 level. And an exponential expression is any expression which contains a power. So this that I've written here, which we can call x to the n, is called a power. And a power has 2 pieces to it. One of the pieces is called the base, and one of the pieces is called the exponent. And it is very important, I believe, in high school math and further math to make sure that you're using the proper terminology. So when we talk about whatever that thing is on the bottom of a power, we refer to it as a base. When we talk about whatever is on the top, we refer to it as an exponent. And that is what it's called. It's called an exponent. It is not called anything else. The entire thing is a power, and the power contains a base raised to an exponent. What does that mean? What does x raised to the exponent n mean? We can also call it, by the way, the nth power of x, but I don't know anybody who ever refers to it as that. I would prefer that you just call it x raised to the exponent of n. It means that whatever x is multiplied by itself n times. So if I had x multiplied by itself 15 times, then rather than writing x times x times x, etc. 15 times, I could simply write x raised to the exponent of 15. Very often, an exponential expression contains, as well as containing a power, because it has to contain a power, it contains what's called a coefficient. And a coefficient is simply a number that you're multiplying the power by. And this first example may seem very, very elementary, but it illustrates something that's crucial in your understanding of working with powers. We're asked to identify here the coefficient, the base, and the exponent for each of these exponential expressions. So to begin with here, I would like to highlight, well, I'll rewrite this so I've got a little bit more room. I would like to highlight in this first expression the fact that 3 and x raised to the 5 together make up the exponential expression. Specifically, the coefficient is what I have highlighted in blue, and what I have highlighted in yellow is the power. So the entire thing is an exponential expression. It consists of a coefficient multiplied by a power. The power has a base and an exponent, and the base of that power I've highlighted in yellow is x, and the exponent is 5. The coefficient is the number we're multiplying the power by. If we take a look at b, b means negative 4 to the 6th. Let me repeat that. b means negative 4 to the 6th. I've put a deliberate pause in between me saying negative and me saying 4 to the 6th, because it doesn't mean negative 4 is being raised to the 6th. It means this is equal to negative of 4 to the 6. In other words, and this isn't just trying to be tricky or make things complicated for students. This is an important thing I want you to understand. The power is 4 to the 6, and the coefficient is this negative out in front. But a coefficient is supposed to be a number. So what is that number? That number is negative 1. So when you see something like negative 4 to the 6, it means the coefficient is negative 1. The power is 4 to the 6, which means the base is 4, and the exponent is 6. Let's take a look now at C. In order to understand what the coefficient is in C, I think most of you would guess that the base is x and the exponent is 7, and you would be right. In order for you to understand what the coefficient is, you need to appreciate that when you divide something by 3, that is the same as multiplying it by 1/3. So just to be complete here with all my highlighting, x to the 7 is the power of this exponential expression. The coefficient is 1/3. So the coefficient is 1/3. Of course, when you have a power of x to the 7, the base is x, and the exponent is 7. Feel free, of course, whenever you need to pause the video to write something down or to think about something, to do so. The first thing to note here is in your handout that I've printed out for you, the exponents on each of these exponential expressions is 5. And I would like you to change that 5 to a 6. So just take a minute and do so. So instead of being negative 2 in brackets raised to the 5, I want it raised to the 6. And instead of having negative 2 to the 5, I want it as negative 2 to the 6. So this illustrates more what I was getting at earlier in the difference between where we say the negatives. This is said on the left for A as negative 2 all to the 6. And sometimes what we will say, and you will get used to this, is for A we will say negative 2 quantity to the 6. And that means the negative is also being raised to the 6. What this means, and I don't want us to use our calculators. The purpose here, everybody, in this course is not for you to grab your calculator and start typing stuff in. When the time comes, I will guide you in that direction. But for the time being, we have to do a little bit of thinking here. And because you've chosen to take Math 10C, that means you're either going into dash 2 or into dash 1 in grade 11. And these things are important. You have to be able to think about these values without automatically jumping to your calculator. So negative 2 raised to the 6 means negative 2 multiplied by itself 6 times. What have I got? 5 so far, 6. On the other hand, when we take a look at B, B is negative of 2 to the 6, which means negative 1 multiplied by 2 to the 6, which means negative 1 multiplied by 2, by 2, by 2, by 2, by 2, by 2. Now I can't stop you from using your calculator, and I will show you the proper way to enter it in a second. But as you're going to see a little bit later, those 2's or those numbers are going to become variables or letters. And you can't enter them into your calculator. So what you need to remember from previous grades is that when you multiply a negative by a negative, you get a positive. So these two negatives together will give us a positive. These two negatives together will give us a positive. And these two will give us a positive. So essentially, if we have an even number of negatives being multiplied together, you're going to get a positive. So this answer will be positive, and we need to figure out what 2 multiplied by itself 6 times is. Well, 2 times 2 times 2 is 8. 2 times 2 is 4. Multiplied by another 2 is 8. So it's 8 for the first 3 2's times 8 for the second 3 2's, and that gives us positive 64. When we take a look at B, well, this is going to be the same 64 that we got on the other side, except this negative 1 is being multiplied by the 64, so negative 2 to the 6 in part B is negative 64. Now, I guess it is important that you know how to use your calculator. If you want to figure out on your calculator what A is equal to, then you have to make sure that you put a set of brackets and then the negative 6, and then you can, pardon me, and then the negative 2, and then raise it, and that's this button underneath your clear sign, raise it to the 6, and you get the right answer. If you want to figure out what in B negative 2 to the 6 is, you just put negative of 2 to the 6. And your calculator knows it means negative 1 times 2 to the 6. It's important that you don't confuse those two. All right, let's talk about the exponent laws now. So we are asked to simplify each of these expressions using what we know about powers. For example, 3 raised to the exponent of 3 is 3 multiplied by itself 3 times. So this is this part, and 3 raised to the 4 is 3 multiplied by itself 4 times. And that's this part. So how can we rewrite 3 raised to the exponent of 3 multiplied by 3 raised to the exponent of 4? The answer is we can write 3 raised to the exponent of 7. If you count all of those 3's that I have there, you'll discover there are 7. 1, 2, 3, 4, 5, 6, 7. So 3 raised to the exponent of 3 times 3 raised to the exponent of 4 is 3 raised to the exponent of 7. If I look at a to the 8 times a cubed, that is a times a times a times a times a times a times a, 1, 2, 3, 4, 5, 6, 7 times a. This is a to the 8. And we're going to multiply that by a further a times a times a, which is a cubed. And if you count the a's, you have 11 of them. So this is a raised to the 11. This was 3 raised to the 7. I don't care what 3 raised to the 7 is. That's not the point. The point is you recognizing, and this is the law, that when you have a base raised to one exponent and you multiply it by the same base power raised to a different exponent or another exponent, you can combine the two by writing a single base and adding the exponents. So this is called the product law. When you multiply powers together with the same base, you add the exponents. What about the quotient law? Well, this quotient word means divided. So if we have 6 to the 5 divided by 6 to the 2, that means we have 6 multiplied by itself a total of 5 times. This is what 6 to the 5 means. Divided by 6 squared, which is 6 multiplied by itself twice. Going back to some very early junior high-ish kind of stuff, if you have a factor of 6 on the top and the bottom, you can cancel them. So we can cancel 2 pairs of 6's and be left with just 6 times 6 times 6, which gives us 6 cubed. So 6 raised to the 5 divided by 6 raised to the 2 is 6 cubed. If I look at this next one, I have a multiplied by itself 10 times. So there's 5. I'm getting a little tired of writing, so I'm just going to clone this piece. This is the a to the 10, and we are going to divide that by a to the 6. And if you want to take a minute and count all of my a's on the top of this and all of my a's on the bottom, you'll discover there are 6 on the bottom and 10 on the top. Basically, all 6 of these on the bottom cancels with 6 of these on the top, and what we are left with is only 4 on the top, so we're left with a raised to the exponent of 4. And there's a connection here between the exponents before we divide and the result of the division. It's that you subtract the exponent in the numerator minus the exponent in the denominator. In the first part on the left, 5 minus 2 gives us the new exponent of 3. In the second part on the right, 10 minus 6 gives us an exponent of 4. So here is our rule that you will typically see on a formula sheet. When you have x raised to an exponent of m over x raised to an exponent of n, it's equal to x raised to the exponent of m minus n. You subtract the exponents. The third law is often called a power of a product, and what that means is we have a base that is a product and it's raised to an exponent. For example, 7 times 4 in brackets raised to the 3 means 7 times 4 multiplied by 7 times 4 multiplied by 7 times 4. So I'm multiplying 7 times 4 by itself once, twice, 3 times, because it's cubed. And what do I get? Well, if you count the 7s in here, there are 3 of them. And rather than writing 7 times 4 times 7 times 4 times 7 times 4, I could write this. And you don't need to write all of this down. You can just observe a lot of what's going on. But I can change the order that I write these numbers down. The order in which you multiply numbers doesn't matter. So I have 3 7s and I have 3 4s. If you did the same thing with the second one, you would have AB multiplied by AB, multiplied by AB, multiplied by AB, multiplied by AB. And you would discover you have A to the 5 in there and B to the 5. So this is typically how we would write this law. We would say when you have x times y raised to an exponent, that exponent gets applied to both x and y. Whoops. It gets applied to both x and y. If I have 5/9 raised to the 4, that means 5 over 9, multiplied by itself a total of 4 times. So there's 2, there's 3, and there's 4. One of the rules you learn about, and there's a reason for it, but we're not going to get into the reason here in grade 10. One of the rules about fractions you learn about is when you're multiplying fractions, you multiply across the top and you multiply across the bottom. In other words, basically what's going on here is this. These are multiplication symbols, not x's. And what you discover is that on the top of this expression you have 5 to the 4, and on the bottom you have 9 to the 4. We could do the same thing here, but I think you're getting the drift. This will be a to the 7 over b to the 7. And this rule for a power of a quotient is typically written as x over y raised to an exponent of m is equal to x to the m over y to the m. Now, I wrote m here. I could have written n, I could have written p, I could have written any letter. The important thing is you understand the exponent is applied to the top and the bottom. We're almost done with reviewing the exponent laws. We've got a couple more. A power of a power means, and I'm just going to rewrite this, that you have a power raised to an additional exponent, in this case 4. So what does that mean? It means 7 cubed, and I'm going to write out 7 cubed as that. that will be multiplied by itself 4 times. So there's a second time, there's a third time, and there's a fourth time. And what you discover is you end up with 12 sevens. So 7 cubed raised to the exponent of 4 gives you 7 to the 12. We could do the same thing here. A to the 4 is 4a's. If we have a total of 6 of those, that's 1, there's a second, there's a third, there's a fourth, there's a fifth, and there's a sixth. See, at some point you have to come up with a rule because you don't want to have to do this and start counting all of these things. There are going to be 24 because you have 6 groups of 4. So this becomes a to the 24. And if you haven't clued into what's going on here, when you have x raised to an exponent and it's raised to an additional exponent, the entire thing is raised to an additional exponent, then you can write it as x raised to the product of m times n. We can multiply the exponents. The zero exponent law. Well, let's just think about this for a second. How could I get 0 for an exponent? Well, what if I had 7 squared over 7 squared? Well, we know according to and I'm just going to go back and show this to you, we know according to this law, not this one, my mistake, we know according to this law here that when you have 2 powers that you're dividing and they have the same base, you subtract the exponents. So if I have 7 raised to the 2 divided by 7 raised to the 2, according to that other law, this is 7 raised to the 2 minus 2, which happens to be 7 raised to the 0, because 2 minus 2 is 0. But we should know, everybody, that this entire expression is equal to 1. This whole thing is equal to 1. 7 squared over 7 squared is 1 because any number divided by itself is 1. We could figure it out. 7 squared is 49 over 7 squared is 49. Oh, 49 divided by 49 is 1. So for that reason, any base raised to an exponent of 0 is equal to 1. Now there's an exception to that. So x to the 0 is equal to 1. The exception is x is not allowed to be 0. We don't need to worry too much right now about why that's the case. Basically, if x were 0, you would have 0 to the 0, and that is not defined. So these are all of the exponent laws that you have encountered in mainly grade 9, but you might have encountered them back as early as grade 7, depending on what your teacher was doing and how you were learning your math. Now what we're going to do, so this is kind of the first part of the lesson. What is a power? A power is a base raised to an exponent. What is an exponential expression? It's a coefficient times a power. And here are all of your exponent laws. And the last half of the lesson is going to be us applying them. And I'm not going to go really slow here. You have a pause button on your Chromebook or your phone or your laptop or your desktop computer or whatever. If you need to pause and think about things, do so. 3 squared times 3 to the 7. We're not asked in this question, number 3, to evaluate these. I don't want to know what this is equal to. I want to express it as a single power. And it's going to be 3 raised to the 9 because when the bases are the same, you add the exponents. So this is equal to 3 to the 9. You do not need to write this. Most students at this level are going to look at 3 squared times 3 to the 7 and go, oh, I add the exponents. I get 3 to the 9. So this is your answer. 3 squared to the 7, that means 3 raised to the 2 multiplied by 7. This is the power of the power rule. If you have to, then you can think of 3 squared to the 7 as 3 squared times 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 3 squared. I think I have one more to go. 2, 4, 6, yes. 7, 3 squared. And then you could add up all of those exponents. And you're going to get 3 to the 14. So this is equal to 3 to the 14. By the way, when I say if you have to do this, I'm just saying maybe you're writing an exam and you're stuck and you've forgotten what to do to the exponents. I'm not meaning to imply that that's what you should do all of the time. Over here, when you divide powers that have the same base, you write it as a single base, and you take the top exponent and subtract the bottom exponent. So we end up with negative 3 raised to the 2, because 7 minus 5 is 2. And although we aren't asked to evaluate this, you should know that a negative squared will give you a positive, so there's nothing wrong with writing 3 to the 2. Negative 3 to the 2 means negative 3 times negative 3, which will give you a positive. So it's positive 3 to the 2. This is our answer, or this is our answer. Evaluate. So evaluate means find the value of. And we want to express all answers as integers or fractions. This is not about throwing the whole thing into your calculator. If that's the only way you can do these questions, then you're not going to be successful in other areas of high school math. You have to be able to think without a calculator. So all this means is 1 over negative 3 squared. So in my brain, and you can write this down if you like, but in my brain, I'm thinking negative 3 times negative 3. Well, negative times negative is positive, and 3 times 3 is 9. So 1 over negative 3 quantity squared is 1 over 9. I don't often do this at this level, but I want to explain to you at least a little bit why it's important that you can do this without a calculator. Very shortly, things are going to become algebraic and not numerical. In other words, we're not going to be dealing with bases of negative 3. We may be dealing with bases of negative x. Or we may be dealing with bases of the cosine of x. Things are going to ramp up in high school math. Okay, let's take a look at B. Well, B is kind of an interesting one. B has this thing, I'll call it, 3x squared plus 2y cubed minus 4z squared, but it is raised to the 0. So you should know the 0 exponent law means you're going to get 1. Now take a look at C. C is not going to give you 1, and I'm highlighting this idea that C says negative 3 to the 0. I'm highlighting this idea. I think this is the third or fourth time. That this is a coefficient of 1 and it's multiplied by a power of 3 to the 0. And if I've highlighted it 3 times in 25 minutes or whatever it is, you better believe that I think it's important. It would be a shame for you to start getting questions wrong in grade 11 math next year because you don't understand this little thing. So we gotta pay attention to the details here, everybody. So this is negative 1 times 3 to the 0, but 3 to the 0 is 1. So negative 1 times 1 is 1. So this is our answer here. Sorry, negative 1 times 1 is negative 1. I don't know if I said negative 1 or not. If I didn't, I apologize. But this gives us negative 1. This is our answer. This is our answer. And this is our answer. Three halves, quantity to the 4 means 3 to the 4 over 2 to the 4. You are asked to express your answers as fractions or integers, and I think it's best for us to figure out what 3 to the 4 is. 3 to the 4 means 3 times 3 times 3 times 3. Don't grab your calculator. I can have a vision in my head of some of you grabbing your calculator, but I want to, over the next few years, leading up to grade 12, break you of that habit so you become better at math. 3 to the 4 means 3 times 3 times 3 times 3. Everybody should know what 3 times 3 is. It's 9. That means this is 9. And I hope everybody knows that 9 times 9 is 81. So we have 81 on the top. And I guess if you're stuck, you could use your calculator. You could take your calculator and go 3 raised to the 4. Oh, it's 81. On the bottom, we have 2 raised to the 4. Well, what is 2 raised to the 4? 2 raised to the 4 is 2 times itself 4 times. This one is easier than 3 to the 4. It's 2 times 2 times 2 times 2. This is 4 times, this is 4. So it's over 16, and this is our answer. All right, example 5, what is the difference between 3x squared, which I'm going to write down here, 3x squared. What's the difference between that and 3x squared? So if I don't worry about the inflection in my voice and trying to put those pauses in there, I would pronounce the one on the left 3x squared. And it means 3 x squareds. If I were to pronounce, without trying to use my voice to give you a hint, what's on the right, I would say 3x quantity squared. So what is the difference? The difference is that over here, the 3 is squared. Right? We can even use the power of a product law to say that this thing is equal to 3 squared times x squared, or 9 times x squared. You can also arrive at 9x squared by saying this is 3x times 3x, and simply taking 3 times 3 to give you 9, and x times x to give you x squared. On the left, it just means 3x squared. There's nothing we can do with it. And again, these are things that I believe are important for you to be successful moving forward. Understanding the difference between these two things. How are they different? We're in the home stretch now. We're going to take a look at 6, just a whole bunch of rapid fire questions where we are simplifying the expression. If you want, what you can do just to kind of test your abilities here is you can pause the video, do A and B, and then watch the little part of the video and see how you do. The answer to question A is going to be, it will be equal to A to the 14. And you should be getting to the point where you simply say, oh, it's the same base, and I'm multiplying, so I'm going to add the exponents. 9 plus 5 is 14. You shouldn't need to think of writing out a times a times a, etc., 9 times, and then 5 times, and then counting a's. Over here, leading up to something for tomorrow, if I have 3y squared times 4y to the 5, that means 3 times y squared times 4 times y to the 5. I can change the order of these. I can say 3 times 4 and y squared times y to the 5. And I can certainly multiply 3 by 4 to get 12. And I can multiply y squared times y to the 5 by adding the exponents to get y to the 7. All of this is not necessary. I think most people will just say, I'm going to multiply the coefficients and I'm going to multiply the y's and be done with it. B, well, on the top we have x to the 13, and this is how your brain should be operating very soon. When you see x to the 9 times x to the 4, your brain should be processing that and seeing x to the 13 because you add the exponents. So we have x to the 13 over x to the 3. Well, now we're dividing powers and we subtract the exponent. So this is going to be x to the 13 minus 3, which will give you x to the 10. And I suspect a number of you, of the 8 students that we have right now taking Math 10C, I in my head say at least 6 of you could probably go directly to this answer without much thought. Over here, I'm going to rewrite this slightly. This is 30 over 20. And we're multiplying it by a to the 8 over a to the 5. And we're multiplying that by b to the 4 over b cubed. So we can reduce 30 over 20 down to 3 halves. And we have a to the 8 over a to the 5. And if I subtract 8 minus 5, I get 3. So I get a to the 3. And then b to the 4 over b to the 3. I subtract the exponents and get b to the 1. I certainly don't need to write b to the 1, but I'm going to put it in nonetheless. So that's the answer to D. E, this means 3 to the 5 times p to the 5. So we need to figure out what 3 to the 5 is. I know it's 243. I think, although I've said a couple of times here, don't automatically go to your calculator. There comes a time in your life where you understand how valuable the calculator is as a tool. Why don't we just calculate 3 raised to the 5? Oh, it's 243. Maybe, just maybe, you'll do this 3 to the 5 enough times that you will remember it's 243. Maybe not. So we get 243 p to the 5. Fg, quantity to the 6. This means f times g, quantity to the 6. So it's a power of a product. It's what we call a power of a product, which means a product raised to an exponent, in this case of 6. We apply that exponent to both factors of the product. So it's f to the 6, g to the 6. Negative 5 mn quantity to the 3 means negative 5 quantity to the 3 times m to the 3. We don't need the brackets around the m because it's not negative, but I'm going to put them anyway. And then n to the 3. So negative 5 to the 3, negative 5 times negative 5 times negative 5. Well, negative times negative times negative is a negative. We're going to get a negative answer. 5 times 5 is 25. So we're going to get a negative. Times another 5. Maybe you know that that's negative 125. I hope you do. If not, you can feel free to use your calculator. And then we have m cubed, n cubed. Over here, this means negative 5 to the 4 times m to the 4 times n to the 4. So we're definitely going to get m to the 4, n to the 4. But this is going to be positive because we have this negative number multiplied by itself 4 times. So negative times negative will give you a positive. Negative times negative will give you a positive. This whole thing is going to be positive. And I think when you multiply 5 times 5 times 5 times 5, and you can check this with your calculator, you're going to get 625. And that's it, my friends. We're done the first lesson. My thinking here in the environment that we're learning this in is that you should complete the lesson, which you have presumably because you're listening at this point in the video. And then there are practice problems on pages 4 to 8 of your handout. And I think it's up to question 22. And many of those questions have part A, B, C, D, etc. Just some observations. First of all, I think you should be spending the rest of today and tomorrow at school working on those problems, practicing those problems. I know that some of you are at home for a variety of reasons. We are an outreach school, so you're not always there. But that means that at home, you should be doing the problems on pages 4 to 8. I'm going to leave it blank and tell you that you need to do enough of these problems that you get better at the math. This is your goal. We're not in junior high anymore where I'm going to tell you you have to do this question and this question. You have to do enough of these questions that you get better at math. And by the way, if I say there are 22 questions, so it's 1 to 22, some of these questions does not mean you do 1 to 11. It means you do some of the questions in 1 and some of the questions in 2 and some of the questions in 18 and some of the questions throughout the whole set of problems, because they get more difficult as you go up in number generally. So the plan that I would like for us is we do a lesson and then we have the remainder of that day plus the next day to practice. And if you're practicing from home, I can't really help you, but if you make it into school, I can. And then on the 3rd day of the unit, we'll do the next lesson. And then on the 5th day of the unit, we'll do the next lesson, and it will proceed in that fashion. So I hope that made sense to you. Get to work on those problems, and I hope to see you soon. Take care.